Good morning, class. How's everybody doing today? Today, we're going to move on in our organic chemistry and talk about the concept of isomers, which is a very important concept in organic chemistry as you move on through your science careers. Isomers in organic chemistry tell us that we can have the same formula, but a different structure. So if you think about your hydrocarbons you were doing the other day, sometimes we're going to get the same exact formula, but the structure, the way it's built, is going to be different. And because the structure is different, the name is going to change and tell us that the isomer is indeed true. Now, when we're doing isomers, we have to understand that there are going to be two new important pieces that show up. And we're going to see mostly today only one of those pieces. And then I'll give you an example at the end of the other piece. When we move things around to change the structure, you're going to get two new things called methyl and ethyl. Methyl is CH3. Ethyl is C2H5. And notice, just like in hydrocarbons, the meth still means one, and the eth still means two in terms of carbons. So you have to understand that in lower level chemistry, we only use the smaller pieces, 1 carbon, 2 carbons. But as you move on to higher level chemistry, there's also going to be these things called propyls, butyls, pentyls, so on and so forth. Everything on table P can be an ill if the compound is big enough. So today we're going to focus more on the methyl because we're going to deal with smaller compounds. Ethyl can only show up when it's a bigger compound. We're talking about 7 to 8 carbons or more. So here we're going to see CH3 or C2H5, or it might be drawn out, a C with 3 sticks with H's, 2 C's attached with 5 H's, right? But the key thing is going to be these two things have to be in the middle of a hydrocarbon. And because it's in the middle of the hydrocarbon, we're going to be able to use our numbering system to name what the compound is to show what the location is going to be. Now, when we're doing isomers, we're also going to notice that I can tell something's an isomer, yes, if the structure is different, but sometimes it's not as easy to tell. So I like to use this little drawing here on the bottom. I call this my little caret or my little blip structure. The reason for this is if I'm going to draw or trace carbons in a hydrocarbon, if I stay in one motion and not trace over the same line twice, I would know nothing changed. So notice if I go across like this, nothing changes. If I go here, up, over, down, over, up, over, nothing changes. I did not trace over any carbon or area more than once. But with this little structure, if I was coming across and then I had to go up, but the only other way to finish was to come back down in the same spot and then move over, I'm going to get this little blip or caret structure. That's going to tell me I created a methyl or an ethyl, and therefore it's going to be an isomer. Now, you might be thinking, oh, that's going to be tough to do, but it's actually pretty easy because remember, in organic chemistry, and this is why I love it, what you see is what you get. There are very few tricks as long as you know the process. All right, so let's take a look. Here I have something you should be familiar with from yesterday. This is C4H10, right? If I had asked you, what is this? I would go to table Q, plug in 4 for N, 4 times 2 is 8, plus 2 is 10. I know this is an alkane. I know my alkane has 4 carbons, table P. P, prefix for 4, is bute. This is butane. So the question becomes, Does butane have any isomers? And if it does, what are they? Well, an isomer, by definition, again, the formula is the same, but the structure is going to be different. So I have to ask myself, can I change the way this looks, keep the same formula, and then the name changes? And the answer is yes. And if you can remember the rule of the two extra pieces, the pieces have to go somewhere in the middle. So to make an isomer, it's very simple. To start, you take a carbon from the end and you move it into the middle. So I'm going to take this carbon off and I'm going to move it in the middle. So watch what happens. Notice now, instead of going 4 carbons across, I went to 3 carbons across, and that extra carbon I now placed in the middle. And notice what we have now. I have a CH3, which is one of my 2 important pieces. Now, again, I could have drawn this out with the CH3 looking like this as well. And you'll see that as we move on in some of the structures. So once I have my structure, I have to check, is it the same formula? So if I count 1, 2, 3, 4 carbons, good. 1 and 3 is 4, 5, 6, 7, 8, 9, 10. This is also C4H10. So notice, excuse me, the isomer definition holds true. Both of these things are C4H10, but the structures are different. They look different. And my piece added to it is, if the structure changes, the name also has to change. And now this is something that you have to know how to do, using our knowledge of hydrocarbons and now isomers. Notice I went from 4 across to 3 across. Well, we know that if there's 3 carbons across, now it can't be a bute, it must be something else. On table P, the prefix for 3 is prop. My carbons are single bonded. Table Q tells me this is an alkane. So 3 carbons, single bonded, is propane. But this is not propane. If it was, this would just be an H, not CH3. So now my important piece also shows up in the name. I have a CH3. I have to remember CH3 in the middle is called methyl. And just like we did with double and triple bonds, it is going to need a number to tell its location. So if I number this 1, 2, 3, or 1, 2, 3, notice this methyl gets the same number. So what this structure actually looks like is 2-methyl propane. Notice, just like I said before, what you see is what you get. It's a propane base with a methyl on the second carbon, so it's 2-methyl propane. Now I also want to trace my carbons to see if indeed I have that little blip or caret. Notice here I would just go straight across, no change. But here, look, when I trace my carbons, I get to this one. I have to go up to this carbon and come back down before I can go across. So that is the blip or caret that we were talking about. That is a correct isomer. So now the question is, can I make something different but still have C4H10? And notice there's only one spot in the middle. So there's no other isomer that exists for butane. And that's because a small number of carbons can only have a small number of isomers. So in this example, butane only has one isomer. All right. Now, again, you have to watch that a couple times just to get the hang of it, but I'm going to move forward. All right. And we're going to see as the number of carbons increases, so does the isomers. All right. So let's take a look. Here I have C5H12. So now from yesterday, you should be a pro at this. 5 times 2 is 10 plus 2 is 12. This is an ane. It's a 1, 2, 3, 4, 5 carbon ane. This is pentane. So the question is, can I make pentane have isomers? And if butane already did, we know pentane's going to definitely have them, but probably even more than one. So let's see how this works. Remember, easiest way to do it would be take a carbon off the end and bring it into the middle. So I'm going to have this structure here. Now notice what I did. I went from 5 carbons across to 4, and I put 1 in the middle. This time, notice I did not write it as CH3, just to show you the other way you might see it. I actually drew it out as CH3. So now I want to check, is this also C5H12? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is C5H12. So it is an isomer. But now I want to name the isomer that I just created. So again, we know how to do this. I have 4 carbons across in my chain. They are single bonded, so I know that's a butane. I have a methyl group on this carbon chain. And notice it's on the 1, 2 carbon. If I go this way, it would be 1, 2, 3 carbon. So it must be a 2-methyl butane. Again, you may want to watch that one more time to see how that's done, but it is what you see is what you get. Now, here, the question becomes, just like before, are there any other isomers that I can create? So I ask myself, can I move this methyl over to here? And does the structure and name change? And if you move this over to here, it looks like it changes, but it actually doesn't because it's a mirror image. If I put a mirror right here, it would look the same. But also notice the name does not change. If I move this methyl over to here instead, it would then be counted 1, 2 methyl butane again. So I can't move this methyl. Now, when that happens, I just can't say there's no more isomers. I have to ask myself, can I move another carbon and make something different? And notice we actually can. I can take this other carbon and also move it to the middle. So watch what happens. Look what I get. Looks kind of funky, looks kind of weird, but let's see. Is this C5H12? 1, 2, 3, 4, 5 carbons. 3, 6, 9, 12 hydrogens. It is a different structure. So notice here, if it's a different structure, I should be able to name what this isomer is. And it's pretty easy. Notice I have 3 carbons across now. That's prop, and they're single, so it's propane. Pretty easy. Here, though, notice what do I have? I have a methyl here and a methyl there. There's 2 methyls, and where are they? They're on the 2nd carbon. So just like we do before, whatever we add, we have to show the location with a number. So there's 2 things here. So I have to have 2 numbers, and they both, in this case, have to be 2. What is it? They're 2 methyls. So instead of writing 2,2-methyl propane, that's kind of redundant. We say it's 2,2-dimethyl propane. I love organic chemistry. We have to put the location because I need to know where the methyls are. So I just don't want to say 2 dimethylpropane, because that's saying there's only one methyl. So I have to put the both numbers and the prefix di to show what it is. So this is 2,2-dimethylpropane. Now, notice, I have to ask myself, are there any other pictures that I can draw to make it different? And now we're at the point where we can't. So pentane only has 2 other isomers. Notice I went from C4, which had 1, to C5, which had 2. All right? So again, you may want to watch that slide over again. But again, I find organic chemistry very fun and interesting. Call me weird, but I like it. So let's take a look at one more example. Here we have C6H14. 1, 2, 3, 4, 5, 6, 3, 5, 7, 9, 11, 14. C6H14, 6 carbons, hex, they're all single. This is hexane. So now you should be getting into the rhythm and routine of this process. I want to make an isomer, take a carbon off, put it in the middle. So notice what I have. Okay. And notice this time to be different, I put it on the bottom, but that's not going to change what it is. So now I have C6H14 here. 5 and 1 is 6. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have C6H14. It's an isomer. Now, which one is it? I have 5 carbons across. They're single bonded. So that's going to be pentane. I have a methyl on the second carbon, right? So this is 2-methylpentane. Pretty easy, right? So now, what can I do? Remember, you always ask yourself first, can I move this methyl somewhere else to make it different before you take another one off? So notice if I move this one over to here, what does it become? It becomes this. Now I have the methyl not on the second carbon, but on the third. So 5 carbons is still pentane. Methyl now on the third carbon. So that's 3-methylpentane. Now, notice, is there any more? Can I move this over to here? You might be thinking yes, but you can't, because now that becomes just 2-methyl. So I can't move this one anymore in the middle here. So what's the question I have to ask myself? That's right. Can I pull another carbon off and put it in the middle at the same time? And we can. So C6H14 is going to continue. I ran out of room, so I'm going to go to another slide. And here, I can do 2 of the carbons and move them in the center. So notice I still have 1, 2, 3, 4, 5, 6, 3, 6, 9, 10, 11, 14 H's. This is also C6H14, right? What do I have? Again, love organic chemistry. What you see is what you get. My longest carbons are 4. 1, 2, 3, 4. So I know it's a bute. They're single. I know it's an ane. It's butane. But what's on it? I have 2 methyls on the same carbon. So this is a 1, 2 or a 1, 2, 3. That's right. Has to have the lowest number, so it's a 1, 2. So this is a 2,2-dimethylbutane. Pretty cool, right? 2,2-dimethylbutane. So now the question is, can I move it somewhere else? If I move these things over to here, it's still 2,2-dimethyl, so I cannot do that. But there's one more. I can actually move one of these over and it looks different. Take a look. It's like, DeMarco, you magician. I'm not a magician. I just know what I'm doing. So here I could take this methyl and just move one over. So notice, do I have C6H14? And I do. 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14. I do. So what is it? 4 carbons, single, butane, 2 methyls, but this time they're not on the same carbon, so I need 2 different numbers. So this is a 2, 3 dimethyl butane. I love organic chemistry. At this point, there are no more isomers for regular hexane. Now, I know what you might be thinking. We've been doing all anes, and that is true. At our level, we only have to understand how the anes work. But you can do the same exact thing with the same exact process for enes and ines. Just as easy, just these would be different bonds, but we're doing all single. Now, notice my little disclaimer here. We don't use ethyl until we get to 7 carbons or more. Now, rather than going through every possible isomer, and if we had a lab, I would have you do one of the big ones, and you could build it or draw it for yourself. I'm just going to show you what an ethyl would look like. All right? So here I have an ethyl example. Now notice, how do I know this is an ethyl example? Remember what ethyl actually is. Ethyl, we said earlier, was C2H5. Has to be somewhere in the middle. So notice it's right here, C2H5. Okay? And the way this works is you always want to make sure you find the longest number of carbons first. So if I counted by accident 1, 2, 3, 4, 5, 6, that's only 6 carbons. There's actually 1, 2, 3, 4, 5, 6, 7, 8 going this way. So again, what you see is what you get. Check this out. I have 8 carbons in my chain. They're single bonded. That's octane. But on the 1, 2, 3, 4, or 1, 2, 3, 4, 5, has to be the smallest number. On the 4th carbon, I have this thing called ethyl. So this is 4-ethyl octane. Pretty good. All right, so you may want to watch that video one more time. It definitely takes a while to get used to the process, but once you have the process, it's pretty easy to do. All right, everyone, have a great day. Take care.